Welcome back, everyone. Today we're going deep on object detection.
Oh yeah, this should be fun.
Definitely. Our listeners sent in a ton of articles and notes about this topic.
Sounds like they really want to understand how this stuff really works.
Yeah, they want to go way beyond just the basics. So we're going to unpack it all. How does object detection actually work? What are the big challenges? What are the algorithms everyone's talking about?
It's incredible how far this field has come. I mean, it's not just theory anymore. This stuff is powering so many real-world applications, it's mind-blowing.
Okay, so let's start with the fundamentals here. How do they actually see objects? Because it's not magic, right? But sometimes it feels like it.
Well, it all starts with feature extraction. Basically, the computer analyzes the image, right? It tries to identify the key visual elements.
Okay, so what kind of visual elements are we talking about here?
Think about edges, corners, textures. Those are the building blocks of any object, visually speaking.
Interesting. So it's like the computer is an art critic, kind of breaking down the image into its basic elements.
Exactly. It's looking for those fundamental shapes and patterns.
Gotcha. Okay, so the computer's got its magnifying glass out, analyzing the image. What's the next step?
Well, this is where machine learning comes into play.
Machine learning. Everyone's talking about it, but what's actually happening here? Are we saying that computers actually learn like humans do?
That's a really good question. It's not exactly like human learning. It's more about pattern recognition. Think about it like training a dog, to fetch a specific toy.
Okay, I can picture that. So how do we train a computer to recognize objects?
We feed it tons and tons of data. Thousands, even millions of images where the objects are already labeled, like this is a cat, this is a stop sign, this is a banana, you get the idea.
So we're basically creating a visual encyclopedia for the computer to learn from.
Exactly. But it goes deeper than that. The computer isn't just memorizing images. It's learning to identify the underlying patterns, the relationships between those visual features and the objects themselves.
Okay, so the computer's analyzing all this data, figuring out the patterns. But how does it actually do that? This is where those mysterious convolutional neural networks come in, right?
You got it. CNNs are the brains behind object detection. They're special types of neural networks designed specifically for analyzing visual information.
CNNs, convolutional neural networks. I always hear that term, but I'm still not quite sure what it means. Can you break it down for us?
Imagine a detective, right? Meticulously scanning a crime scene, looking for clues.
Okay, got to picture that in my head.
That's kind of what a CNN does with an image.
Oh.
It breaks it down into smaller pieces and analyzes each piece, looking for patterns.
Oh, the computer's kind of dissecting the image, looking for those telltale signs of a particular object.
Precisely. And it does this using something called convolutional layers. Think of them as filters that slide across the image, picking up on different features at various scales and locations.
Okay, that's pretty cool. So the CNN is like a superpowered detective,
Yeah.
scanning the image for those subtle visual cues. But how does it all come together? How does the computer actually say, hey, I found a cat?
That's where the bounding box comes in.
The bounding box.
Yeah, it's basically like the computer drawing a box around the object saying, I'm pretty sure there's a cat right here, and this is its size and location in the image.
Oh, that makes sense. It's like the computer putting a spotlight on the object it's identified.
Okay, so we've got this whole process now. We've got feature extraction, machine learning, the CNNs doing their detective work, and then the bounding box announcing the discovery. But I have a feeling it's not always this straightforward in the real world, is it?
You are absolutely right about that. The real world throws all sorts of curveballs that make object detection much more challenging than it might seem at first glance. Okay, I'm all ears. What are some of those challenges? What makes object detection so tricky?
Well, for starters, objects aren't always so picture perfect, right?
What do you mean?
They can be different sizes, shapes, orientations. They can be partially hidden. They might be poorly lit. It's not like the computer has a perfect template for every object in the world.
Yeah, that's true. So the computer has to be able to handle all those variations.
Exactly. And the challenge is they don't stop there. Objects are often partially hidden by other objects, right? Think about like a car parked behind a tree or a cat hiding under a blanket.
I see what you mean. So if the computer can only see part of the object, how does it know what it's looking at?
It has to make an educated guess. This is called occlusion. It's a real headache for object detection systems. And then on top of that, we've got background clutter.
Background clutter, you mean like a messy room?
Exactly. The world is rarely a clean, minimalist studio backdrop. Objects exist in these complex environments, and trying to separate them from all that visual noise, well, it can be really difficult.
So it's like trying to find your keys in a really messy room, but for a computer trying to identify objects in a picture.
It's a lot to process. And then, to make things even more challenging, many applications require object detection to happen in real time. Think about self-driving cars. They need to make split-second decisions to avoid a collision. There's no time to sit around and ponder.
That's true. It has to be instant.
Exactly. So as you can see, object detection, it's a complex field. It really requires this balance of speed, accuracy, and then robustness to handle all the messy realities of the real world.
Wow, it sounds like a real gauntlet for these systems to run through. But clearly, people are making progress. We've got self-driving cars on the road, security cameras that can track individuals, all sorts of cool stuff happening.
Oh, yeah, absolutely. And a lot of that progress comes down to the algorithms that researchers have been developing.
The algorithms, those are the tools that give computers the power to tackle all those challenges and make object detection actually work, right?
You got it.
Okay, so let's talk about some of those algorithms. What are the big names? Who are the stars of the object detection world?
Well, it really is like a whole lineup of specialized detectives, each with their own strengths and approaches. And first up, we have the RCNN family.
RCNN. That sounds familiar. What does it stand for?
It stands for Region-Based Convolutional Neural Network, and they're known for their accuracy.
So they're the meticulous detectives, taking their time to get it right.
Precisely. The earlier versions could be a bit slow, but then came Fast RCNN and Faster RCNN, which significantly boosted their speed while still maintaining a high level of accuracy.
Okay, so the RCNN family is all about precision.
Yeah.
But what about speed? Like in those situations where you need split-second decisions, like think about self-driving cars. They need to react instantly to avoid accidents.
Ah, you're right. In those cases, we turn to YOLO.
YOLO, what's that all about?
You only look once.
You only look once. That's a bold statement.
It is, isn't it? It processes the entire scene in one go.
So it just glances at the image and makes a decision.
Pretty much. That's what makes it so fast.
Wow, that's amazing.
Yeah.
But doesn't that sacrifice accuracy?
Sometimes it's a trade-off, speed versus accuracy. You have to weigh your options depending on what you're trying to achieve.
Okay, I'm starting to see the big picture here. So we've got the accurate but slower RCNN family, the fast but potentially less accurate YOLO. Are there any other big players in the game?
Oh, of course. We can't forget about SSD.
SSD, what's that one?
The single-shot multi-box detector. It's kind of like a multitasker. It can detect multiple objects at the same time, all in a single pass through the network.
Oh, wow, so it's like YOLO on steroids.
You could say that. It's super efficient, which makes it great for things like mobile devices where processing power is limited.
Right, makes sense. Okay, so we've got precision, speed, efficiency. Is there anyone else we should know about?
Oh, there's one more. The up-and-comer, DETR.
DETR, huh? What's special about DETR?
It stands for Detection Transformer. It uses this transformer technology, which has been a game changer for natural language processing.
Oh yeah, I've heard about that. So they're applying that same technology to object detection.
Exactly. It's still early days, but it's showing a lot of promise.
That's really cool.
Yeah.
It's amazing to see how far these algorithms have come. But, let's step back for a second and talk about the data behind these algorithms. We keep mentioning training, but what exactly are these algorithms learning from?
Ah, great question. That brings us to the crucial role of data sets. Think about it like training for a marathon.
Training for a marathon. Okay, I'm listening.
You need data to track your progress, right? Your pace, your distance, your heart rate. That information helps you improve your performance.
So you're saying data sets are like training data for object detection algorithms.
Exactly. There are massive collections of images that have been carefully labeled to tell the algorithms what they're looking at.
Okay, so it's like a giant visual dictionary for the computer.
Yep.
What are some of the big names in this data set world? I saw a few in the notes you sent over. ImageNet, COCO, PASCAL VOC, what are those all about?
Those are the heavy hitters. ImageNet is massive. It has millions of images across thousands of categories. It's really been a foundational data set for object detection research.
Wow, so ImageNet is like the ultimate training ground for object detection models.
You could say that. Then you've got COCO, which stands for Common Objects in Context. It focuses on everyday objects and scenes, capturing the complexity of the real world.
So instead of just isolated objects, it's more like real life.
Exactly. It helps the algorithms learn to recognize objects in more realistic settings. And then you have PASCAL VOC. It's a classic data set that focuses on specific object types, things like people, cars, animals.
So ImageNet is broad, COCO is realistic, and PASCAL VOC is specialized.
That's a great way to put it. And these data sets, they're constantly evolving, becoming even larger and more diverse.
So the better the data, the better the algorithms become. And that leads to more powerful object detection systems. It's amazing how all these pieces fit together.
It really is. And it's so exciting to see how this technology is being applied in the real world. I mean, it's everywhere. From self-driving cars to medical diagnostics, object detection is changing our lives in countless ways.
That's a great point. We've talked a lot about the technical side of things, but I'm really curious to hear more about how this is all playing out in the real world. Like, what are some of the most exciting applications? Okay, so let's talk real world applications then. Object detection in action. What are some of the most exciting areas where this is all happening?
Well, self-driving cars have to be top the list, right?
Yes, self-driving cars. It seems like object detection is the key to making it all work. I mean, how else would a car see the world around it?
It's like giving the car a pair of eyes, allowing it to perceive its surroundings, pedestrians, other vehicles, cyclists, traffic signs, everything it needs to navigate safely.
So it's not just about recognizing a car, right? It's about understanding where that car is in relation to the self-driving car, how fast it's moving, and even predicting where it might go next.
You got it. It's about creating this dynamic real-time understanding of the environment, just like a human driver would do.
And this all has the potential to make our roads so much safer.
Absolutely. Human error is a huge factor in accidents and self-driving cars. Well, they rely on this very precise object detection, so yeah, they could really reduce accidents significantly.
That's incredible. Okay, so self-driving cars, definitely a game changer. But what about other areas? Where else is object detection making a difference?
Oh, it's everywhere. Security and surveillance, it's becoming super important in that field.
In what way?
Imagine a security system that's constantly monitoring a large area, right? And it can automatically identify potential threats or suspicious activity in real time.
That's impressive. But it also makes you think about privacy concerns, right? I mean, do we really want cameras watching our every move?
That's a valid point. It's definitely a complex issue. Balancing security and privacy is going to be a big challenge as this technology keeps advancing. But hey, let's move on to something a little less heavy. Have you noticed how personalized shopping has become?
Oh yeah, it's kind of creepy sometimes. It's like they know what I want before I even do.
Well, object detection plays a role in that too. Retailers use it to track inventory, understand customer behavior, personalize the shopping experience.
So all those targeted ads that follow me around the internet, is that object detection at work?
That's part of it. But it goes beyond just ads. Think about smart shelves that can tell employees when a product's running low. Or even robots that can stock shelves automatically.
It's like we're living in a sci-fi movie.
I know, right? And the applications go even further. Healthcare is another huge area.
Yeah, I remember reading about how object detection can be used to diagnose diseases. Is that right?
Absolutely. Algorithms can analyze medical images, X-rays, CT scans, MRIs, all that stuff. And they can help doctors identify, tumors or abnormalities, things that might be really hard to spot with the naked eye.
So it's like having an extra pair of eyes, but these eyes are, superpowered.
Exactly. And it goes beyond just diagnostics. Object detection can even guide surgeons during complex procedures, giving them real-time feedback, making sure everything is super precise.
It's mind-blowing how this technology is being used to save lives. Are there any other surprising applications, areas where you wouldn't expect to see object detection?
Believe it or not, agriculture.
Agriculture, how does that work?
Imagine drones, right? Equipped with object detection systems, flying over fields, monitoring crops. They can identify signs of disease, pest infestations, or even just areas that need more water or fertilizer.
So it's like a high-tech scarecrow, but way smarter.
Exactly. It gives farmers this incredible overview of their crops. And we're even seeing robots that can harvest crops, using object detection to pick only the right fruits or vegetables.
It's incredible how one technology is impacting so many different fields. From healthcare to agriculture, even shopping.
And this is just the beginning. As algorithms become even more sophisticated, we can expect even more amazing applications to emerge.
I can't wait to see what the future holds.
Yeah.
Well, we've covered a lot of ground today in our deep dive into object detection. From the nitty-gritty of how it works to the mind-blowing applications that are shaping the world around us, it's clear that object detection is a force to be reckoned with.
It's a truly fascinating field, and it's evolving so rapidly. Who knows what breakthroughs are just around the corner?
That's the exciting part. We're just scratching the surface. So as we wrap things up, here's a thought for you, our listeners. What other applications can you imagine? What problems can object detection help us solve? What new possibilities might it unlock? The future is full of potential, And who knows, maybe you'll be the one to bring the next big breakthrough to life.
That's a great way to put it. Keep exploring. Stay curious.
Thanks for joining us on this deep dive, everyone. Until next time.